So this review video is going to be about learning targets 22 and 23. Learning target 22 says I can calculate the mean, variance, and standard deviation for the number of successes in repeated Bernoulli trials. Learning target 23 says I can calculate probabilities of outcomes from repeated Bernoulli trials. So these two learning targets are related, and people often get them confused what they're supposed to do for each one. So I decided to make a combination review video of these two learning targets. So first, let's just remind ourselves what a Bernoulli trial is. So a Bernoulli trial is some kind of an experiment where there are exactly two outcomes. For example, flipping a coin, you can get heads or tails. It's some sort of an experiment where you can get exactly two outcomes. One of the outcomes we label a success. That's just whatever you want to happen, whichever event you're interested in finding the probability of. That one we label success, and then the other one we label a failure. And the probability of getting a success is going to play a role when we calculate certain probabilities or certain statistics about Bernoulli trials. So let's just jump into some problems. So in this first problem, Brittany has a 90% free throw percentage. So in basketball, when you are trying to make a free throw, your free throw percentage indicates what percentage of the time do you actually make that free throw. And the question is, find the mean, variance, and standard deviation for the number of free throws she makes if she makes 20 attempts. So we discuss some formulas for the mean, the variance, and the standard deviation for the number of successes in repeated Bernoulli trials. So we discussed that the mean is given by n times p, where n is the number of times you do a Bernoulli trial. So in this situation, Brittany is making a bunch of free throws, and each one of those is considered to be a Bernoulli trial because she either makes it or she doesn't. There are exactly two outcomes. She either makes it or she doesn't. N indicates how many of those Bernoulli trials does she do. So how many free throws does she attempt? P stands for the probability of success. So in this problem, we're interested in the number of free throws she makes. So therefore, a success would be making a free throw. Let's just jot that down. Success is making a free throw. So P stands for the probability that that happens. So in this problem, that's 90%. Now in these formulas, wherever you see P, you're going to need to put in the probability as a decimal, not as a percentage. So whenever you're given a percentage, you need to consider that as a probability. For these problems, you always want to put in for P the decimal value, not the 90%. So let's actually do this calculation. Our mean is given by n times p. So in this problem, that is going to be 20 times 0.90. And if we do that calculation, we should get 18. So that means that the mean for the number of times she'll make a free throw out of 20 is she'll make 18 free throws. Okay, so now let's try to calculate the variance. So we also discussed a formula for the variance, which was n times p times 1 minus p. So we're going to take the number of Bernoulli trials we do, multiply by the probability of success on each Bernoulli trial, and then multiply that by 1 minus the probability of success. This is just the probability of failure. So if you think about it in that way, you can. So in this problem, once again, n is the number of trials she does, so the number of free throw attempts that she makes. P is the probability that she makes each free throw. So once again, that's 0.90. Now 1 minus P will be 1 minus 0.90, which is 0.10. So if you actually do that calculation out, you should get 1.8. So finally, we want to find the standard deviation. Now, to find the standard deviation, we know that the standard deviation is always the square root of the variance. So the standard deviation will be the square root of 1.8, which is about 1.342-ish. So now let's try letter B. So letter B says to find the probability that Brittany makes all 20 free throw attempts. So this is an example of learning target 23, where we're looking for a probability, not the mean, variance, and standard deviation. We want the probability. Now the formula for the probability looks a little bit more complicated, but it's actually, I think, a little bit easier to make sense of. So the probability of getting k successes, so the probability of k successes is going to be given by the value n choose k, which we'll talk about in a second, times p to the k times 1 minus p to the n minus k. So this formula looks really complicated, but let's just talk about it piece by piece. So the idea is, suppose that we want k successes. So in this case, we want 20 successes out of 20 free throw attempts. So this part here has us multiply by the probability of getting a single success, k times. This part here has us multiply by the probability of getting a failure all the other times. That's what this n minus k stands for. If there are n trials in total and k of them are successes, this is however many would then have to be failures. This number in front is the number of different ways that out of n things you can pick k of them. So if this problem was saying we want Brittany to make 10 of her free throw attempts, it's asking, well, how many different ways could we pick 10 of the 20 free throw attempts to be the successes? So for example, maybe she makes the first 10 and misses the last 10. Maybe she makes the first 5, misses 10, then makes the last 5. So like, how many different ways are there of actually getting the number of successes that you want? So that's the idea behind this formula. So in our problem here, k is the number of successes. So k is 20. And n and p are the same thing that they were for the first problem. N is the number of trials you do, and p is the probability of getting success on any single trial. So the probability will be given by 20 choose 20 times 0.90 to the 20th times 0.10 to the 0th power. So this part tells us how many ways are there of choosing 20 of the free throws to be successes. This part has us multiplied by the probability of getting success on each individual free throw. It has us multiplied by that 20 times because we want 20 successes. And then this is the probability of a failure. We get it by doing 1 minus the probability, raised to the power of however many failures we want. Now we need our calculators to actually do this calculation. So just as a reminder how we do this on our calculator, So what we're going to do first is we're going to, inside parentheses, we're first going to type in the first number 20. Now to get this choose thing, you need to go to the math button on your graphing calculator. You're going to arrow all the way over to the option that says PRB, which stands for probability. And you're going to go down to number 3. It looks like NCR on your calculator. You'll hit enter. Then you're going to type in the last number, 20, and close your parentheses. And then just type in the rest of this. And I got out 0.122-ish. So this is the probability that Brittany makes 20 out of her 20 free throw attempts. So let's do one more example so that we can sort of get the hang of it. So in this problem, Mrs. Runge has a special coin that lands on heads 5% of the time and tails 95% of the time. She plays a game where students can choose to flip the coin, and if it lands on heads, they don't have to do their homework, but if it lands on tails, they have to do extra homework. So letter A asks us if all 18 students in our class decide to flip the coin, find the mean, variance, and standard deviation for the number of students who get to skip their homework. So let's think about what our n value and what our p value is in this situation. So remember, n is the number of trials we do. In this case, each trial is a student making the choice to play this game and flip the coin, and we see what do they get? Do they get heads or tails? So in this case, there are going to be 18 trials because we're saying all 18 students do this. So that is our n value. P, remember, is the probability of success. Now in this problem, we want to know about students who get to skip their homework, so a student getting to skip their homework is what we're considering success. And remember, students get to skip their homework if the coin lands on heads. So the probability of success is 5%, which as a decimal is 0.05. Now we know that our mean is given by n times p. In this case, our n is 18 and our p is 0.05. And if we multiply this out, we should get 0.9. Next, our variance we know is given by n times p times 1 minus p. So in this case, we have 18 times 0.05, that is our p-value. 1 minus that is 0.95, so we multiply by that at the end. If we multiply all of this out, we get 0.855, so that is our variance. Finally, to calculate our standard deviation, we're just going to take the square root of the variance, so the square root of 0.855, and we get about 0.925 for our standard deviation. So now let's do letter B. Letter B says to find the probability that exactly one student out of the 18 students will get to skip their homework. So that's going to be, our probability will be given by 18 choose 1. So that's the number of different ways we could pick one student to get to skip their homework, times the probability of success, 0.05, raised to the first power because we want one success, times 0.95 raised to the 17th power, because if out of 18 students, one of them is a success who gets to skip their homework, the other 17, those are failure events where the students have to actually do extra homework. So once again, we need to use our calculator to calculate this. So I'm going to open up some parentheses and type in the 18. To get this little choose function, remember we have to go to Math, arrow over to Probability, down to the third option which says NCR, hit Enter, and then type in the last number and close your parentheses. That'll give you this first part. Then we're going to just put in the rest of this and multiply everything all together, and I got about 0.376. So let's just quickly review how we approached these problems. There were two different kinds of problems we talked about. Learning Target 22, where you calculate some statistics, mean, variance, and standard deviation. And Learning Target 23, where we're talking about calculating probabilities of different kinds of outcomes. It's very important to read your question carefully to see what you are being asked. We know these formulas for the mean, variance, and standard deviation. Those ones sort of look pretty straightforward. The one for probability looks a little bit more complicated, but remember you can just think of it as the number of ways of choosing k successes out of your n Bernoulli trials times the probability of getting a success raised to the power of the number of successes times the probability of getting a failure raised to the number of failures. And in these problems, make sure that you are both showing what you are plugging into your calculator and a decimal value. I'll typically ask for rounded to 3 decimal places.